Up next is a presentation on variable rate irrigation from Mark Johnson and Kevin Cussen. Mark is a professor at the University of British Columbia and president of Ensemble Scientific. Kevin is a product manager for LiteFarm. I will load up the presentation for you all.
Hi everybody, this is Baarda here. I'm out at Farming Smarter's field site, the quarter section just across the road from our office here. If you've been to our events, you've been here before. So I'm going to start by giving you a bit of an overview for this project. Our partners at the University of British Columbia obviously couldn't be here today, so I'm going to be the in-field presence, give you a bit of background to what we're working with. And this is a good site to sort of demonstrate some of these concepts because it's actually quite a variable site. So I'm standing right here. This is sort of the crest of the hill in the field, but if you look behind me, there's actually a pretty good depression, kind of in that, I guess that would be the southeast corner of the field. And we do notice that when we get plenty of precipitation, we do get flooding in that part of the field. And one of the things that's really challenging for us to manage is irrigation in that scenario, because no matter how wet it is, this hilltop still needs water, whereas that depression, it gets over full of water. But we don't know, depending on the year, how much we need that water, and that's sort of where this project comes in. So our partners on this project are working on a system for variable rate irrigation. And I'll let them get into the specifics of what their objectives are and what their work plan is for that. But the gist is, it's really tough to implement variable rate irrigation. And one of the reasons for that is, one, we've got lots of variability in the soil. And two, the technologies that we have for it, they're often static. They're not really dynamic. And when I say static, I mean, we build a prescription, we collect information ahead of the season. So we might do a bunch of soil sampling throughout the field. We might do some EC mapping. We might do some hand texture analysis, all these pieces. But once we kind of get in season, we've built our zones, we've built our management zones and decided how to handle them. But it's really difficult to make changes in season with everything else happening. So what we're going to try to develop here is a more dynamic system, something that can be responsive to what's actually happening in the soil. So that means we're going to be placing plenty of soil sensors throughout the location. It won't be this field, but this is just a good demonstration for it. But soil sensors throughout the field that are going to tell us exactly what's happening with the soil moisture at any given time, and our irrigation strategy can respond real time to that, and it'll be an autonomous response. So as a farmer, we won't have to go in and adjust things. It'll decide things for us, and all we have to do is verify that we're comfortable with the decisions being made. So yeah, so it's a pretty exciting project. We think there's a pile of potential for some of this technology, because as we talk to irrigation farmers, there's a lot of hurdles that we kind of go through to get the right water in the right place at the right time in the field. And when you get to a variable field like this, a static model for variable rate irrigation just isn't effective enough. So excited to sort of dig into a more dynamic approach. So with that, I'll pass the torch, so to speak, to Kevin and Mark, and they'll dig into some of the specifics, some of their roles in the project, and exactly how we plan to implement this technology.
Thank you, Louis, for that introduction. My name is Mark Johnson. I'm a professor at the University of British Columbia and president of Ensemble Scientific. We got started with Ensemble Scientific to address some of the needs in soil and water monitoring and the flows of data that we were experiencing in research and with our research partners. And we're really excited to be partnering on this research with Farming Smarter and with LiteFarm. So as Louis was stating, the problem that we're really facing is, can be summed up in the simple statement that soil is variable. But what does that variability look like? So here's a slide showing the clay content in soil in the field that Louis was standing in. And we see that, it varies from 18 to 44%. This is in the 30 to 60 centimeter horizon. So that's a change within this one field by more than 200%. So that's quite a lot of variability that has to be contemplated when we're thinking about irrigation prescriptions. And certainly variable rate irrigation can account for this variability. And so we know that a lot of this, the changes in soil texture and changes in topography will affect a lot of features related to water availability, how water moves through soils and becomes available to plants. But when we think about that, we can also understand how these changes in soil texture and related properties affect what we can refer to as the bucket size of the soil. So by bucket size, I mean how much water are we able to hold in the soil? And so we often see this expressed as the available water holding capacity, which is simply computed as the difference between field capacity and wilting point. And so here we see the data from the field at Farming Smarter, where Lewis is standing, aggregated up to through the different soil layers down to 1 meter deep. And we can see that the amount of water that can be stored in these soils varies quite a bit as well, largely as a function of soil texture. But it means that the amount of water that's going to be held there varies by about 40% within this one pivot. And so that's something that we need to be able to take into consideration. We also need to be thinking about other features as we go to implement moving from a static form of VRI into a dynamic VRI. So how can we go about implementing a dynamic VRI, which some people will refer to as precision irrigation. Others you might have heard call it smart VRI. So there's a number of factors that will come into play. Some of them are that we need to consider real-time soil water status. So not only what is the bucket size, what is the topography, what is the soil texture and soil organic matter content, how that affects water availability, but what is it in the day-to-day variability? We need to know something about the current status of water availability in soil. We also need to be thinking about the crop growth stage. So at different, just after emergence, the crops are going to be a lot more sensitive to water stress. And then later on in the cropping cycle, you might be wanting to stress the crop a little bit depending on what you're growing. So all of those come into play when we think about the dynamic prescriptions that we can build up. And we couple those with field data with weather forecasts. So we know something about certainly the next few days, what's coming up in terms of winds and humidity in the atmosphere, how thirsty that air is to dry out soil. But also we can think about the near-term water use of the crops and put that together with what the atmosphere is doing and look at how much water we have available in the soil at that time relative to how much is needed in the next, let's say, week or two, compared to how much we need to be sure that we have on hand for later stages of the cropping cycle. So those are those remaining crop water requirements we're thinking about. So this just gives you kind of a infographic looking at, spatial variability within a pivot, kind of a cartoon thing. We wouldn't want to see a field get so variable in water content, right? That's going to lead to yield reductions. It's going to lead to other undesirable aspects. So we can look to variable rate irrigation as a means to maximize yields, as a means of saving water, minimizing nutrient leaching, minimizing runoff from the fields, possibly erosion. And then also, if we're minimizing the amount of water that we need to put down, that's allowing us to save energy. And when we save energy, we're also saving money. And in addition to saving money, we're also reducing CO2 that might be resulting from all the pumping to get water into the fields. So, we can think that in the coming years, low carbon agriculture could lead to payments for these CO2 savings beyond soil carbon sequestration that might be coming along as a result of no-till farming. So these are just different ways that we can think about how VRI can affect the bottom line. And we've seen that VRI is getting adopted quite widely in Australia and New Zealand, with currently more than 30% of the pivots there operating on VRI technology. Many of those still just in the static mode rather than this dynamic prescriptions that we're talking about. At the same time, in North America, VRI is catching on more slowly, and it's estimated by the industry that only about 5% or less of pivots at present are using VRI systems. So we're hoping to find a way to encourage the growth of that, because we think it can really really help farmers and the sector in general. So how are we approaching this to move into more of a dynamic VRI? So we're looking at developing in this project a data-driven full stack precision irrigation system. What does that mean? Well, we're thinking of that as on the one side, at the field side, really a highly detailed, quality assured soil moisture maps that are derived from sensors in the soil and real-time transmission of those data, essentially moving information from the soil to the cloud. And in those databases, we'll be able to operate those in the next stage of the full stack. And we want to highlight that the sensors that we're developing they're based around measuring soil water potential, and the nodes or data loggers and transmission units that these are connected to are all going to be assembled and value added in Alberta. So we're really excited about bringing together different components of the supply chain, and then doing the value add in Edmonton, actually, with our with Logican Technologies, which is a contract manufacturer. And so they seem great as an electronics assembly house, and we're excited to be able to add this value in Alberta to through the project. Okay, so when we get those data coming in from the sensors and transmitted into the databases, then we'll use those to generate soil moisture maps, kind of like this cartoon that you see in the bottom corner. And these will be updated daily and combined with weather forecast, crop data, and ET models. And that will happen in the LiteFarm portion of the stack. But what we want to recognize is that there's information that can come in different scales. Farmers can provide more detailed information as they have it for soil texture, EC mapping, etc. These sort of soil parameters, and those can go to really help refine the type of prescriptions that the dynamic VRI can produce. And then it will come along and we'll know how much space is left in the bucket, what's the depletion rate at present, what's the depletion rate looking like based on the near-term weather forecast, and how does that affect what a farmer might need to do in terms of ordering water and making sure they don't get behind the curve in terms of keeping enough water in their bucket for later stages in the cropping cycle. Okay, so those all of that information will be harmonized and evaluated, and then these dynamic irrigation prescriptions will be transmitted from the LiteFarm platform into the VRI operating system, the computer of the VRI system. And before that gets implemented, that means the farmers will get a chance to review, apply their own judgment, and accept or postpone the suggestion. Okay, so what does this mean for farmers and agronomists? Overall, our project goal is to make it easy for farmers and agronomists to implement precision irrigation. And key considerations for this implementation include that the ease of use is really paramount. We want to be able to install sensors in the soil in a way that doesn't interfere with other farm operations. We want that data to just start flowing from the field into the cloud without a lot of setup and troubleshooting and things like that on the producer's part. And crucially, we're using these soil water potential sensors in part because they respond more directly to what the roots are experiencing in terms of water stress than a soil water content sensor does. And they're also less reliant on calibration. And so that's, I think, really interesting for this. It allows us to think about irrigation triggers that are really finely tuned to the crop in the field, as well as its crop stage, and the threshold that the producer thinks is appropriate for moisture status that the crop can tolerate at that stage. You know, there'll be guidance, and then things can be fine-tuned and adjusted by the producer. Okay, and so that'll allow us to use the soil water potential as the irrigation trigger, and with that we can bring the soil back to field capacity or whatever level is deemed appropriate based on the crop stage and irrigation practices. For example, you might be using a strategy for full irrigation, trying to get back to field capacity after every irrigation event, or you might be practicing some deficit irrigation to bring it to a level that's below field capacity. Also important is that producers and any agronomists that they're working with have access to the soil data and cropping information and cropping schedule and weather forecast and all that information, just one-stop shopping where it can all be viewed. And then we want to provide automation with oversight. So with this, we're going to have these dynamic prescriptions that are updated every day. If you as a producer are of the opinion that the prescription is not the right one to be implemented, that perhaps based on your experience, it's better to keep going with the current conditions before triggering an irrigation event, there'll be the chance then to accept or not accept that suggestion, and then the prescription suggestion will be updated the next day based on the current conditions and evolving weather forecasts at that time. And it's also important that these systems be affordable, and so we're looking at really providing a value proposition of robust sensor arrays that are reasonable, low cost, and are implemented and utilized throughout with this LiteFarm open source platform to ensure that you as the producer have access to your data and are able to implement this precision irrigation, dynamic VRI or smart irrigation, smart VRI, to the extent of automation and et cetera that feels appropriate. So now I'll hand it off to my colleague, Kevin Cussen, to tell you a bit about LiteFarm.
Thanks, Mark. Hi, as Mark mentioned, my name is Kevin Cussen, and I'm the product manager for LiteFarm. Thanks so much for joining us today. I'd love to tell you a little bit more about how LiteFarm is going to support our project to create a data-driven full-stack precision irrigation system. So the first thing that I can tell you is that the app is available via browsers. So that means you can access it directly from a traditional device like a laptop or from your mobile device. And we've really optimized it for the mobile experience, just so that users can take advantage, out in the fields where they need to have information. There's a bunch of features that really support our goal of creating a dynamic, incredibly accurate soil moisture map. But first, I want to talk about two kind of high-level concepts. And the first is that the system is open source. So there's no chance of getting locked into a vendor. Anyone that wants to use LiteFarm can take the code, they can modify it for their own purposes, and they can resell it as a product if they're interested. Second, our data policy is incredibly pro-user. So essentially, data that you enter into the system is yours and remains yours forever. So if you used LiteFarm for 6 months, decided that it wasn't for you, but wanted to take the data that you had collected in the system, you're absolutely welcome to do that. We don't sell your data. We don't market it, use it for commercial purposes. The only way that data is used is supporting research. And for any data that's being used for research purposes, it's anonymized before being shared with scientists. In addition to that, there's a few kind of core features to LiteFarm that make it really powerful for taking the sensor data that we'll be collecting and then visualizing it and making it actionable for farmers and agronomists. First is that we have a really rich crop catalog. We have about 400 different crops that LiteFarm makes available, as well as about 100 data points for each of those crops. So that means that as we're putting together your automated irrigation prescriptions, we're taking into account a lot of data points for the crops that you're growing. In addition to that, we've got API integrations with weather systems as well as soil type services. So that means that we're getting live feeds of the weather around a particular farm to help estimate, precipitation, as well as EV calculations based on the hours of sun and temperature. In addition to that, we've got a soil API that will estimate at a fairly low granularity level kind of the soil type for any given farm. Obviously, if a farmer documents or an agronomist documents a core sample, that's going to increase the accuracy in the system. But we've got a baseline for basically any farm that wants to start on LiteFarm today. In addition to that, we've got support for about 20 different types of tasks that are pre-generated in the system, and then support for any number of custom tasks as well. So a big part of this project, would be kind of expanding the irrigation portion of the system in order to support, dynamic irrigation prescriptions and autonomous irrigation prescriptions. In addition to that, we've also got kind of high-level insights, holistic insights as to the impact of your particular operation. So a few things that I'd love to discuss are some of the project milestones that we expect. So this is a short project. This is phase 1. And we hope to be talking about phase 2 of this project in a year and a half. But we will be wrapping up in December of 2022. So within the next month or two, we plan to have some of the initial designs for how we'll visualize and how we'll allow individuals to act on the data that's coming in via these sensors inside the LiteFarm platform. So we're really interested to have a group of individuals that would be interested in giving us feedback as we work on those designs and let us know how we can improve them over time. The initial release of the irrigation module with support for a Zematic Precision VRI module will come out around March, and we would love to go back to that feedback group and get their feedback on that release as well. We expect to have the first soil sensor arrays actually in field at the Farming Smarter test site around May of next year, at which point they'll start streaming data directly into the LiteFarm platform. And then we imagine that we will be releasing a version 2 of the irrigation module around June. So this will be based on data streaming from the field, as well as fixes and other suggestions from the initial release and the feedback from users that are taking a look as well. In December, we expect to communicate kind of the outcomes of the project and hopefully talk about a phase 2 with a larger group of individuals taking a look at it. So, it's been my pleasure. My name is Kevin Cussen. Once again, I'm the product manager for LiteFarm. Thanks so much for taking time to listen to our project on behalf of myself and Mark from Ensemble and Lewis from Farming Smarter. We hope that you like what you hear. We'd love to get you involved in the project if you're interested, and we look forward to answering any questions that you may have.
All right. Thank you, Mark and Kevin, for that fantastic presentation, and for Lewis for showing us the field across the road. Since we couldn't be there today, it would have been muddy anyway, right? We got some rain today, so. I will open it up to questions. As has been all day, you are welcome to type your question in the chat. You can turn your video on or raise your hand. Do encourage you. I know it's the end of the day and we're all been here all day, but yeah. Encourage you to ask some questions. So in the meantime, I guess I'll ask a question of you guys. You had mentioned at the end of the presentation that you're looking for producer cooperation. What exactly it is that you're looking for? How many producers? What's the requirements? What do you have that you need?
Yeah, sure. I can take this. So the scope of this project is that we're really only doing one implementation of sensor arrays into the ground and testing it. So it's a very small scale. But what we would really love input from producers and agronomists on is the visualizations, right? Because that would scale to a further phase. As you know, if we did a phase 2 that had 10 different producers, we can take those same visualizations and use it for any number of kind of operations using LiteFarm. So the feedback that we're looking for in the short term is, you know, we're going to mock up screens to kind of visualize the information that we described in the project. We'd love to show that to farmers, get their feedback and say, no, that's not how I think about it. I think about it this other way, or like this isn't actionable, it needs to have this, so that we can make sure to really create a user interface that is as good as it can be and actionable for the people that need to take action based on what they see.
That makes sense. Scott, did you have a question, or you just like your camera on because you're such a good sport? Okay, no questions. I guess I'll ask another one. Do you have any rural internet connectivity issues? So Southern Alberta has a lot of locations where, you know, connection is a struggle. So how does that fit into what you guys have going on?
Sure, I can take this one. There's a range of means to get the data into the cloud. So it's what we call the backhaul. And we go from the data being collected in the data loggers, and we can transmit them to over long distances, several kilometers even, to a gateway that is internet connected. Other means are you can have something in the field that's got a SIM card in it if there's cell communication available. But in the case that there isn't, then it just kind of can bounce from the field, repeated as necessary until it can get back to somewhere where there's internet. We might be out of luck if there's absolutely no kind of, it's not even broadband, just some kind of decent transmission rate.
Yeah, and on the LiteFarm side, you would need to have internet access to see what's going on, to see the visualizations, to be able to change the prescriptions and such. But otherwise, the actual generation of the prescription is going to happen without any user input. The only time that you would need to have a connection is when you want to look at it and say, like, yes, I agree, or no, I'm going to keep the current prescription.
And is that just cell connection then, or is that specifically internet?
For LiteFarm, you would need internet. So if you have a good enough cell connection that you can do data over the network, then that would be sufficient. But you would need internet for LiteFarm.
Okay. Ken, did you have a question?
Sure. Hi, guys. Thanks for joining us today. It was actually one of the coolest days. It rained today, so it's ironically not a bad day to have a digital conference, but everyone's sick of it. One of the things that kind of excited me about this project was sort of the data density, because right now there are a lot of different companies that are out there that'll sell you one sort of soil moisture probe, and then they charge you $1,000 a year for data connection and all that sort of thing. I was wondering if you could describe how your sensor arrays might be different.
Right. So we're aiming for lower cost sensors to begin with. That tends to be a bit of the upfront cost. And then, so instead of $1,000 a sensor, it would be something more like $100 a sensor, perhaps less. We're still working on supply chain issues, which have gotten crazy in the past few months. You might have seen a lot of this in the news with silicon chip limitations, and it's affecting automobile manufacturing, everything else. Things are going up really fast on that end, so it's not going to change our price point dramatically, but it's still a little bit uncertain. And then with the data in the cloud, we're not looking at that as being a major revenue source for the for Ensemble. And then the data is, needs to be archived in the database, and then it'll be passed along to LiteFarm, which is open source and Kevin, you can describe the user experience there, but yeah, it's a completely different model from your standard thing is where you're paying an ongoing licensing fee with the data managers and providers.
Yeah, and what I can say about LiteFarm is, I'll reiterate, any data that's in LiteFarm that you have generated or, a device under your farm has generated is your data, right? So if you wanted to get an export of your data at any point, you can do that. We'll send it to you. If you want to remove your data from the platform, you can do that as well. I think, Ken, unless I was mistaken, you were talking about kind of the density, the amount of data that you would be producing. And I think kind of the gist of that is, since the sensors are low cost, we'll have many more in the field than kind of a $1,000 sensor would allow. Mark, is there anything you want to talk about, like the placement, the density?
Right. Yeah. So that's what we're going to be working on in this first year of the project, is to really try and figure out what is the where's that trade-off between cost and resolution. So you could put in, let's say, 1,000 sensors, and you would have extremely granular information. But it might be that you can get a lot of that information through soil surveys or other forms of soil information, and maybe it might be okay just to have a few sensors or a dozen sensors and that kind of thing, and you would know based on your soil variability, then certain features of the data will be more or less representative, and you can get by with fewer sensors. So what we're going to do this summer is deploy really high density arrays of sensors. That's what Lewis was alluding to in his portion. And then from there, we'll be able to do some numerical modeling and some leave one out kind of things, and see where those breakpoints are in terms of going from trying to optimize the system for information, right? We can collect a lot of data. We want to do that in such a way that it generates useful information that can then translate into knowledge. So, maybe that's going to be 20 sensors on some pivots, maybe others where it's more uniform, it might just be 3 or 4. Others, high value crops, you might want to have more dense arrays, but all of that is a little bit of your mileage may vary, and a little bit of we'll be learning more as this project progresses.
You guys also had mentioned something about weather stations being incorporated. So do you have weather stations, or plan to have weather stations on the farm that you're going to be tagging into, or is there an existing system that you'll be tapping into?
So
so that would be, oh, go ahead, Kevin.
Yeah, I can answer really briefly. From the LiteFarm side, we just tap into the Open Weather API. So depending on how close the nearest weather station is to you, it could be really accurate, it could be not accurate at all.
Yeah, and so then as well, the trying to make sure that we have the information that can lead to good decisions. It might mean that we need at least a rain gauge at each pivot at places where that is highly variable. If you have thunderstorms that are raining in part of your field but not others at times, presumably that information is going to be showing up in the soil moisture, but it might be that you would want to have additional rain gauges, and we'll be measuring the other parameters are really wind speed and relative humidity. Those are the sort of the key ones to understand for doing ET modeling and near-term soil water depletion estimates.
Well, southern Alberta is windy and dry. Yeah, relative humidity is low, wind speed is high. Yeah.
Right. Yeah.
So
that all means the atmosphere is very thirsty, and then you have to make sure there's enough water in the soil going forward, and as that is getting depleted, make sure that we can queue up water in time for it to not get below the kind of point of no return.
Right. And Kevin, you were saying about open API weather stations. So do you have any idea what it might look like in Southern Alberta as far as what's available currently?
No, I don't. We can pull that information from the Open Weather Service, but I haven't looked specifically for Southern Alberta. I don't know what the density of weather stations is there.
Okay, no worries. All right, well, that was fantastic. I thoroughly enjoyed all the presentations today. So I want to re-thank all of our speakers for tuning in and joining us. On behalf of Farming Smarter, thank all of you for tuning in. Hopefully you picked up some tidbits and learned some things along the way.